Hi all, this is the MakeHaven badging video for the Shapeoko. So the Shapeoko is a CNC router. What that means is it's computer numerically controlled. It means it's controlled by the computer. So anytime where you want something done that would be difficult to do by hand, either because you want it to be really precise or it's a cool design or something that requires milling with a bit in a way that would be difficult by hand, this could be the tool of choice. So for example, if you wanted to make a perfect circle without drilling a hole in the middle for a jig on the bandsaw would be one example, or you wanted to do a name in a cutting board, or you wanted to do an inlay. These are all examples of when you might use the Shapeoko. There's some examples around. This is one where the bit cut down and then it was filled with resin to make a sort of inlay. These are some others where there's a walnut veneer on plywood, and using the bit you can cut through the veneer and then it pops. So there are a lot of different uses. The mill part of the CNC mill, or CNC router name, means that the bits that it's using can cut down, but they can also cut sideways. So versus a normal drill bit, they can only cut up and down, these can cut sideways too. So that's what this is. The size of the bed, of the cutting area, is about 30 inches by 31 inches, so that's kind of the biggest footprint you can work with. And there's no variable speed control, which means that you just pick the speed and that's what you get. And for the most part, I'd say for the vast majority of cases, that's totally fine. So in terms of controlling it, we are going to use this computer, and it uses a program called Easel, which is web-based, which is really nice because that means you can do all of your designing outside, either on some of the MakeHaven computers or on your own computer, and then just log in here and get them. And that's nice because then your computer doesn't need to get dusty and sit here while this is doing its thing. So we'll look at how Easel works here. If the computer isn't on, then just turn it on. We'll go to Google Chrome, and it looks like there's even a link right there, but I'm just going to go to easel.com. And it brings us to Inventables, and we'll click on Explore Easel. And now it already logged us in to the MakeHaven account. So this is just a general account that you're more than welcome to use if you just want to make something quickly. But if you want to bring in something from your own account, then you'll want to make a free account with Inventables so that you can make it on your computer and then log in here. So we'll just click on New Project. So the workspace that we have has a bunch of cool things. So this is where we do our designing, and this dotted line shows the size of our workpiece. And over here on the right side is a simulation showing our workpiece. And so whatever we do inside these dotted lines will show up over here. We'll start from the beginning. So you're going to choose your material. So here you choose the type of material and its dimensions. So the type, we have a piece of wood here that's oak, and we'll try to find oak in this list. And I don't see oak, but oak's similar to soft maple, so we'll just choose that. And that just helps inform the computer what kind of settings to use for how quickly it should move. And then in terms of the dimensions, it looks like about 18 inches by 6 to me. So X is the dimension side to side, and then Y is the dimension forward and backwards, and Z, the thickness, is the up and down. And so this is pretty important, so we'll just measure this to make sure, and this is 3/4 of an inch. So here we'll select 3/4, 0.75, we're good to go. And so now this piece of wood here represents the piece of wood we have on the table. And then later we'll look at these other settings. So in terms of what we can do here, there are a bunch of things we can choose from to make our design. This is one example of taking a bunch of different shapes and putting them together. So we'll zoom in so we can see more easily what's going on here. So you can see that this is a box with a bunch of other shapes added to it. And we'll just delete what they made because we'll just make it ourselves. So we have different shapes here. And so the shapes you can, for example, select a square. And with a square, you choose the depth of cut So because we told it that our material is 3/4 of an inch, that's the deepest you can go. That would cut all the way through. So you can see in the simulation there's a hole there. Or we can go halfway through. And now it's, if we zoom in here, you can see there's just like a little dent, little cutout there, but not going all the way through. So that's if we want to cut in a fill. So fill means it will cut out all the material on the inside. Outline means it'll cut just on that line that we made. But then we have a choice when we do the outline of whether to do on the path, so that bit is going to follow the square that we drew. Outside, that means it will leave a hole in the shape of the square that we drew, or inside, and so then on the outside will be the line that we drew. And that may seem trivial, but that can be very important depending on what you're trying to do. Then some other things you can do are click edit points. So what that means is that you can take these points and move them around. So this makes it kind of like Inkscape or something, or Illustrator, where you have sort of the vector editing capabilities. You can just drag these points around and make it whatever shape you want. You can also tell it, say for this corner, to make it curved. So now it's a curved point, and you can edit it like that. And then we're going to click on shape. And this, the first option under shape, is the position. And so we're going to zoom back out here. And so this is X, the X coordinate, and this is our Y coordinate. And right now, when we have this shape, it's talking about the lower left corner of the shape. So it's putting an imaginary box around this weird shape we made and saying that the lower left-hand corner is an X position of 0.5, which is right about here, and a Y position of 0.6, which is there. So it's saying that the corner of this shape is right about here. So that could be useful, but let's say we wanted it to be a little, let's say we wanted to refer to the middle of the shape, which is right there. So let's say we wanted to get circles or something where the middle mattered. And then you can say we want the middle of it to be at 3 inches and 2 inches high. And so that's one way of controlling the position, if you want to be more precise about the position of your design on your workpiece. And then the size, this allows you to just scale it up and down. So you can lock it here, and we'll say we want to make the width actually 3, and now it just made the whole thing bigger. You can rotate it, and those are most of the choices there. And then for each shape, they're pretty similar. There might be some like a star. Yep, no, that's the same too. So for the shapes, that's how it works. For the line tool, you just draw points. There we go. So you click escape to get it to recognize your line, and then same deal. For drill, let's say you want to drill holes in your piece, so you can mark exactly where you want those holes to be, and it will drill a hole right into it. Text is another good one that gets used a lot, and so here you have your text, same idea with whether you want it to be outline or fill. I think this is a good point to start talking about the bits that we're going to be using. So let's zoom in on this word text. Let's say we use a really big bit for cutting this out. It won't be able to get in this corner because the bit is a circle. And so if it's a big circle, it's not going to be able to make that nice crisp corner. So we need to just figure out how crisp you want it to be. So that means if you want it to be really crisp, use a really small bit, but that means it'll take a while. So that's a balance you need to sort of figure out. But we can look at over here how you make that choice. Now is 0.15 inches. And that means that's the diameter of the bit. But here we can select the most common types. So here 1/32 is a pretty small bit. And then 1/16, 1/8, and these are all upcut bits. So it even gives a little description here, but an upcut bit is gonna spin and pull the chips out of the hole. And what that means is it's good for getting the dust out, it's good for cutting quickly, but it's gonna leave kind of a rough finish up at the top edge because it's just tearing the material out. Some of the other kinds of bits are down cut bits, so that's gonna be worse at getting the chips out, but it'll leave a smoother finish on the top and a rougher finish on the bottom. So that's a trade-off. Then there's a whole world of kinds of bits. There are compression bits that are upcut and down cut. There are straight cut bits. There are V-cut bits in case you want to just do some lettering or something where you just have a V. And conveniently, there's a little shopping cart right next to it, so you can buy them right from them. In general, what I do is I just type in the diameter because that's the most important piece. So let's say we're using a 1/4 inch bit, which is pretty big. You'd put in 0.25. And now you have a 0.25 inch bit. So if you were to go out and buy bits on your own, it would be kind of annoying to wait and pay for shipping. So we have a few bits here for sale. So those are over here. These CNC bits we have a few sizes. I think they are all up spiral bits. So these look like 1/4 inch. I think they're 1/8 and 16th inch bits. So you can pay at the cash box by the 3D printers or at makehaven.org/store. And here they're the prices. So it's like $6 for a 16th, 8 for a 1/4, and 12 for a 1/4 inch. And so that's one option, or you can get them yourself. Or in this box, we just have some public spares that have been left over. So you're welcome to pick among these. So we'll look more at those once we actually put the bit in the machine. But the point we were trying to make before is that right now we put a bigger bit in here. So right now we made it a 1/4 inch, and we'll see what happens here. And you can see that the letters look pretty mushy. And we'll take this text and make it smaller just to exaggerate this point. So here, if I made text really small, and then we go and zoom in here, we'll click simulate. So simulate's in this lower right-hand corner, and it's going to see what it's gonna look like. And you can see that the word text doesn't even show up because our 1/4 inch bit is too big to fit inside of those letters. But if we made the word text bigger, then it starts to show up. But you can see that it doesn't look great. Like it can't get into a little bit of the E, most of the T. So let's say we want it to look better, we would then try using, say, an 1/8 inch bit. You can click on here. And now it looks a lot better because that 1/8 inch bit can get in there. It still doesn't have the sharp corners, the rounded corners, because it's a rounded bit. And then to go to the extreme, we could use like a 32nd inch bit. And now that starts to look much more like it looks here. So you can see the trade-off though is that the time is going to take much longer. And the way that we get around that is by clicking this plus bit button, and then it lets us use a detail bit. The bigger bit is going to be taking out most of the material, that's this one. And then the detail bit, the smaller one that's going to be doing just the detail work, is this one. So here it has to be a smaller bit obviously because it's just doing the detail stuff. And so that can be a way of getting both the detail and saving yourself time. So that's kind of how the bit selection works. And then we're going to finish up the things over here. So icons, nothing crazy, they're icons. And then these are pretty cool. So these are apps. And here, these are like little programs within Easel to let you do neat things instead of figuring out all yourself. So for example, for an inlay, you would make your design and then click on this app, and it would make the 2 cutouts. So you need one cutout to cut out your material that's going to be going in your, for example, cutting board. And then your other one is going to be doing the part that's removing the wood, the negative piece. And so this automatically does that for you, instead of you trying to have to figure out how to make those 2 match up. So it's just there's a little video here to show you what that means. So we'll make these 2 pieces. So you'll cut out one half, cut out the other, and then you have this little piece, and it fits in just like that. There's a box maker. So this is a pretty good one if you just want to make a quick box with Shapeoko. Puzzles, mazes, fidget spinners. So these are fun to poke through. A feature in Easel that's really useful is called tabs, and that is under the cut settings. So if we have something like this text, right now we're not cutting all the way through, but if we were to cut all the way through, then the middle of the T would be totally loose and would come flying out, and the bit could break, it could come flying out. It's all kinds of bad. So these little tabs, these little yellow things pop up, and what they are little raised pieces of wood. So the bit will come along, come up, over, and down. So it will still be attached by a little piece of wood, and then when you're done, you can just use a little razor blade or something to cut through the tab. And over here, you can control whether or not you want it to use the tabs, the length of them. So right now they're a 1/4 inch, 0.08 inches high, which is good for most things, but if you have like a worky material and 0.08 might not get through, you can increase it. And then here you can control the quantity. So let's say for here, we had a bunch more letters, we would need more tabs to get to all of those letters. And you want to make sure that your tabs are covering all the little bits and pieces. So the middle of the E here is going to come flying out. So you need to make sure that there's a tab that's going to hold that piece of the E in there, and similar over here. So that's pretty important to make sure that all the pieces stay where you want them to stay. That's like one of the most common ways for a cut to fail on the Shapeoko. And then last, but certainly not least, is importing. So let's say you had an SVG, a vector file. You could import it right in here, and then it would use that line to trace. You could import G-code. So let's say you used Fusion 360 or SolidWorks and wanted to import that G-code into here, then you would click G-code. To go into that a little more deeply, this machine using Easel has 2.5 dimensions of movement, or axes of movement. So that means is that it can move X and Y totally fluidly, but if you wanted to do things at 2 different layers, you would have to set them here. So we could have our text, for example, at 1/4 inch, and then this line all the way through, but the bit would move around and then go to a different depth and move around. It wouldn't make smooth curves between those different depths. That would be fully 3 axis of movement. So Easel doesn't do that, but if you wanted to do that, you can do it in something like Fusion 360 or SolidWorks, and then you would use their CAM program. So CAD, computer-aided design, lets you design it, and then CAM is computer-aided machining, which actually comes up with the G-code, and G-code is what tells these motors what to do. And so you can use, and then Easel is CAD and CAM put together. So using something like SolidWorks, you could come up with that code, the G-code, and import that directly into here. And then that would get rid of all these options, and it is just going to do exactly what you tell it to do. So you need to make sure that you're feeling pretty good about what you tell it, because if you tell it to run right off the side, it's going to try to do that. If you tell it just to go straight down, it's going to do that because it's just listening to whatever you tell it to do. So that's importing. Another cool one is image trace. So let's say you have an image and you want to try to use it in Shapeoko, it will try to trace it for you, which is similar to like a vector trace feature in Illustrator or Inkscape. And then you can import a DXF file. So those are the options here. Then we're going to go and look quickly at our cut settings before we go over to actually getting this thing started. So cut settings are how it cuts. So it gives us these recommended settings. Feed rate is how quickly it's going to move side to side. Right now it's set to 28 inches per minute. Plunge rate is how quickly it goes up and down. Depth per pass is how much it takes off each time it goes. So that's for the roughing. And then for detail, it has different settings. Well, they happen to be the same, but you can set them differently. So let's say you're doing your cut and you see, actually this is taking a long time, it can go faster, then you could increase your feed rate. Or actually it looks like the bit's bending a little bit, or I broke this really small bit, then you would slow it down so it doesn't do that, doesn't overload the machine. And then last down here is the fill method. Offset is more of a spiral, and raster goes back and forth. Oh, it looks like raster is only for pros, so we just have offset, which has always been fine for me. So those are the cut settings. All right, so now we've told it that we are going to do, and just for the purpose of this, we're gonna get rid of the detail bit, so I'm just gonna click this little X, but it's not much different. So we say we have an 1/8 inch bit in there, so we're gonna load up an 1/8 inch bit. We're gonna look at changing the bits now. When this is not being controlled by the computer, you can just move it by hand. So we're gonna move this over here, but now to get to under this bit, to get the bit in here, we need to get a little more clearance. So we wanna raise this up. And this axis you can't move by hand, you can only move with the computer. So I forgot to mention this before, but in general, we just always leave this machine on. There is a power switch down here, but, and right now it's on, and you can just leave it on. If you were to turn it off, then the next person needs to restart the computer to get it to talk to it again. So in general, that just stays on. So we're gonna go to carve, and go to Z, and tell it to move up. So that's a little more room to work with. This is the dust shoe that collects dust. You just pull this gray thing out, the yellow thing comes off, and now we have access to the bottom. So on the bottom, there are a few things going on. It's a little hard to see, but I'm gonna push this pin in here, and what that's gonna do is lock the spindle, which will allow me to spin this guy out. And as opposed to something like a drill, which uses a chuck, that you can change the size of, this uses collets, and collets just have one size. So in this collet, you can only fit a size, like one size of bit in here, it goes in here, and then when you tighten it, it pinches it because it has these little slits in it, and then tightens down on it. So you need to make sure that you have the right size collet for the right size bit. So now we'll look at some of these other collets and bits. We selected an 1/8 inch, and conveniently this is an 1/8 inch collet. So this is an 1/8 inch bit that will fit right into it. So that's convenient. But let's say we wanted to do a 1/4 inch bit. Then this is a 1/4 inch collet that's very stuck on the bit. This is also a 1/4 inch. And so you'd use this for your 1/4 inch shank. So sometimes you will have bits that have different size shanks than the size of their actual cutting head. For example, this one. So they're not the same size. So you need to make sure that the part that the collet is holding on to is the right size for that collet. So we'll use this guy. This bit is a little short, so here's a longer one that'll just make it easier to see what's going on. Same thing, just longer. And because this cut I don't really care about, I'm just using them from the public bin. If this was my own cut and I really want it to be really nice, I would want a really sharp new bit, so I'd use one of my own or buy it from here. When you're cutting deep into a material, you need to make sure that your bit can reach that depth. So for a bit like this, the shank is significantly wider than the actual flutes. So you can cut down a 1/2 inch, but after that, this is just going to be pushing into your wood, and it could start a fire just from the friction of rubbing up against the wood at 2,000 RPM. Versus a bit like this, where the flutes are the same as the shank, so this can go even past this 3/4 inch depth. It may not cut super well because the sawdust would have a hard time escaping, but at least it can go that deep. And if you want to try to go really deep, then you grab a bit with even longer flutes so that you can reach deeper depths. So for this is the trickiest part of the whole situation. So first you're just gonna screw this up in there. You're gonna have to hold the pin in to make sure it doesn't spin on you. All right, so now that's in there, you're pushing the pin in, and then slide this up. You have to hold it with your fingers so it doesn't just drop right out. If you aren't holding the bit, it'll just, well, normally it just falls right out. And then you need to tighten it. So now you're using all kinds of body parts to hold it in place. So this, because we're looking at it from the top, you're gonna turn it to the left to tighten it. And there's a little, in case you forget that, there's a little image on the side. So it shows this way is locked and this way is unlocked. So I'm holding this button with my thumb, and I'm holding this with my other finger, twisting and tightening it. And then just to make sure that it's extra tight, I'm gonna grab this wrench off of the wall. And so this goes onto this collet nut, the part that's holding the collet. And again, I have to still hold this top button. It pops in place, and just give an extra little bit of torque just to hold on there really snugly, because it'd be a real bummer if it came out spinning at a few thousand rotations per minute. So then we put our dust shoe back on, and this pin back in. And as you can see, these are just 3D printed, which is kind of cool. And now that's all set up. So now we need to think about how we're gonna hold this material down. And so you can see that there are holes throughout this table for clamps. So we're gonna go over here and grab some clamps. And these are just little levers. We'll grab maybe like 3 of them. And because they're wood, it isn't the end of the world if the bit hits them. It's obviously not great because then we need to make new ones and it'll probably mess up your print, but it's not like anything's gonna catastrophically break. So the way these work is, this is the fulcrum, and it needs to be higher than your piece of wood. So I'm gonna screw these out so that it's a little bit higher than our wood, and then put another screw in, or bolt, excuse me, into here to hold it down. It needs to be at a bit of a downward angle. If it's an upward angle, it's just gonna smush the piece right out. So at a downward angle, I'm gonna hold these in. And I'm gonna grab the screwdriver off of the wall to make this process a little easier. Okay, so that's one, and I'm not screwing it all the way down super tightly just yet. So it goes over here, and I'm just gonna screw that back fulcrum up a little bit more. And because we're not actually doing a lot of cutting, 2 should be fine. In general, you want as many clamps as possible. I would say like probably the most common way for this to fail is that your piece moves while you're cutting, because there's a lot of vibration, There's a lot of cutting forces, so you want it to be really secure. But like I said, we're not totally tightening it just yet. So I'll leave it like that. Oh, okie dokie. So now we're gonna come back over here, and we wanna make sure that this is totally straight. So when we do our design, it's going to be in line with our piece. Let's say you're doing a cutout, you wanted to make a little cutout rabbit. It wouldn't matter if this was straight because it's going to be cut out, so it doesn't matter what its orientation is to the piece of the wood, unless you care about some feature in the wood or the grain or something like that. But here we don't care. Or we're pretending we do care. So we're going to bring this down to the lower left-hand corner, and now we can see the interval. So this is pretty important. Right now it's set to move at 0.1 inches for every click. So I move this, it moves 0.1 inches, but that's going to take us a while to get there. So you can choose 1 inch, and that's going to move a lot. And that's great because it gets us there quickly. However, if I were to click down like 2 inches right now, it would just stick it right into the table and things would break. And so when you're moving at 1 inches at a time per interval, you need to be really careful about how much you're clicking. So it can be tempting to just go click, 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 clicking a whole bunch, and then you realize it's just going to slam right off the side. So you need to, when you're at 1 inch, be really conscious of where you're moving. So I'm going to come over here, and then go X left a little bit, just to get to the ballpark. And I'm going to click down once, and then after that, I'm going to just use the 0.1 intervals. Now it's at 0.1. You can also enter custom controls here, or custom increments. Now get closer, and then I'm going to try to get lined up just with that edge. Right. So it looks to me like we're pretty well lined up with that edge. So now what I'm going to do is I'm going to bring it back up so we can get over that clamp that we put down, put it at 1 inch, and move it all the way over to the right side. And now bring it back down at 0.1. And you can see that the bit is no longer anywhere close to being lined up with our piece of wood. So what we're going to do is just scooch this guy down. There we go. So now it's lined up with the bit again. So now it's lined up with the bit on the right side. We'll run it back to the left just to make extra sure. 1 inch. And I'm going to raise it up a little more so we don't hit our clamp. And down. Oop. Small increment. Maybe over just our hair. So you see this is the process for getting it lined up straight. You could, if you're doing a bunch of pieces, you could like screw or nail or something a piece of wood into here so you line it up with it and it's flat every time. But because so many people are doing so many different things on here, it doesn't make sense for us to have a permanent origin marking piece. So that explains this process. All right, so now let's just clean this up a little bit so we're not doing all these different things. So I'm just going to delete some of these things. So we'll just have this. We'll just do this weird shape. And now a pretty important step is making sure that we're not going to hit the clamp. So we're going to click simulate again. And we can see some of the other things it tells us. It's take about 5 minutes, so that's pretty good to know. And it's going to show us the path that it's going to take. So it's going to start in this corner, and then it's going to come over and just go around. And what that means is we can't have any clamps that are going to be in the path of its travel. So we need to make sure our clamps are over here or away from where it's going to be cutting. So that's pretty important. And it looks like we're good. So we're tucked away in the corner, and now I'm going to tighten these down now that we're sure it's in the right place. Okay. So a little bit awkward, that's tight. And now we're ready to carve. So we're going to go over to carve, and it says measure the material. So enter the exact thickness of the material. We measured it as 0.75 inches. That's important because it was actually thinner and we were going all the way through, then it'd be cutting into the table. And we'd rather not cut into the table. Obviously some people have, but if you are going to go all the way through, try to just go a teensy bit all the way through so that you're not jamming all this deep way into the table. So we're going to confirm material thickness, check. Clamp down the material, we just did that, so material is secure. Confirm your bit, it is an 1/8 inch, so it's actually a spiral, an upcut bit, so let's see if that's an option. 1/8 inch upcut, there we go. So that's a little more accurate. I don't think that'll change anything, but make you sleep easier at night. And then we can go to work 0, So move the machine to the lower left corner of your material. So we're pretty close to the bottom, but we're not at the left corner. So I'm gonna go left, click over, and then the way that I normally do this is I look at it from this position to see if it's exactly lined up on this edge, and you want the middle of the bit to be lined up with the middle, with the edge, not the edge of the bit, but the middle of the bit lined up with the edge of the piece of wood. So that's pretty good. I'm gonna go to 0.01 and go up just a hair. All right, so that's lined up. And then I'm gonna go from this perspective, and it needs to go left. A little more. All right, so that's perfectly lined up there. And then the last trick is taking a piece of paper and putting it underneath here, and you want it to just, so here you can hear that the bit is scraping the piece of paper. And so we'll set it to the smallest setting, 0.001, go down a little more, and so now it's pinching the paper, and that means you're really close to the surface. And if you really want to be super precise, now you can maybe go down one more, just to make up for that thickness of the paper. So now we're all set, where the bit is moved to work 0. Let's say you're doing multiple cuts in a row, you could just click use last home position. And that would mean you wouldn't need to reset the home position, you could just use the one you used before. So we'll confirm home position. Now we're gonna say raise the bit, it's gonna raise it for us. So it just moved up. And we're gonna tell it the dust shoe is attached, confirmed. And we're not gonna turn the spindle on yet, we're gonna turn the vacuum on, which is down here. And this tool is pretty loud, so you're probably gonna want your protection. And then we're gonna turn the spindle on by pulling this up. And then push the spindle on, and now carve. So I just paused it so that we can talk about what's happening here. So the pause button was over here, and that just stops it, but doesn't cancel it. So then we could click play, and it would start up again, but you need to make sure that the spindle and vacuum are back on. Some of the other things you can do here are you can see if it was just going too slowly and you think you can cut faster, you can click the plus button, and it will cut up to 200% faster, or you can go the other direction, you can slow it down. And then let's say something was going badly, something had moved, there's a problem, then you can click the X button and it will cancel and you turn the router off. One of the dangers with this CNC, with a CNC router, is starting a fire. So occasionally a bunch of sawdust will build up and there's air blowing and there's a spindle moving really quickly and it'll start a fire. And so in that case, you should just be able to turn this off and turn the vacuum off and it'll take care of itself. If it's bad, obviously grab a fire extinguisher over on the wall. But in general, the problems that happen here, you can hear, the bit will break, something will move, you can just come over and turn it off and it'll be annoying, but nothing catastrophic. It is important that you stay certainly within earshot and preferably within eye shot of the Shapeoko while it's running so that you can hear if something messes up and see it and react to it. So that's pretty important. However, this can run for hours at a time, so sometimes, if you can just make sure that you're listening to it, normally that'll indicate if there's a problem. If you just wanted to stop it really quickly, you could push the off button, but that's just going to stop the movement. The spindle is still going to be spinning, so you need to turn that off in addition. So then, let's say you did finish the cut, then what we'll do, so I'm going to click play again after I turn the spindle on. It's going to move a little bit, and I'm just going to click the X button to stop it because we don't need to watch it do the whole thing, and it's going to come right back to this position. And if you just let it finish it on its own, it would also come right back to that position. And so it says these are the feed rates and whatnot that we used. If it didn't turn out well, which it suspects because we hit the X button, then you could say sad face and it'll give you some suggestions for how to improve it in the future. And when you're done, the vacuum does collect most of the dust, but you want to make sure that you do any vacuuming up that you need to, put the bits and the clamps away. And have fun making things.